Differentiation Part 1.
Hi hello everyone. For this session we will discuss new chapter differentiation. So first we will discuss the definition of differentiation. See here definition. See here differentiation means the rate of change of one variable with respect to another variable is called as differentiation. See here the rate of change of one variable with respect to another variable is called differentiation. Is called what? Differentiation. Okay. See here, for example, let y is equal to x be any function. So this is any function. See here, if you change the x values, then y values also changes. So see here, for example, if x is equal to minus 1, so what is the y value? Y value is minus 1. If x is equal to 0, so y value also 0. If x is equal to 1, y is equal to 1. So clearly, your y values are depends on x values. So that this variable y is called dependent variable. Y is called what? Dependent variable. And here y values depends on x. So x is called what? Independent variable. Independent variable. Now clearly from this we can say that the rate of change of dependent variable with respect to independent variable. The rate of change of one variable. Here that one variable is dependent variable with respect to independent variable is called as a derivative. Okay. Simply see here the rate of change of y with respect to x. So based on x only y values are changes. So that's why the rate of change of y with respect to x is called a derivative or differentiation. It's called what? Derivative. Simply it is denoted by dy by dx. So this indicates the rate of change of dependent variable with respect to independent variable is called what? Derivative. Okay. So this is the general definition of derivative or differentiation. Now we will discuss the geometrical meaning of differentiation. See here next, geometrical meaning of differentiation. See here, for example, we can consider the coordinate axis. This is the coordinate axis. Both x and y axis are called coordinate axis. Suppose we can consider any line. So this is any line. Okay. How to find the slope of this line? Okay. Here, the slope of line is called also derivative. Okay. So here, derivative means the slope of a line. So how to find the slope of this line? For example, we can consider any 2 points on this line. So this is P point and this is Q point. Here P is x1 comma y1 and Q is x2 comma y2. Now draw the perpendicular line from P to x-axis, Q to x-axis. So clearly this distance is what? Y coordinate of P, that is y1, and this distance is what? Y coordinate of Q, that is y2. Again draw the perpendicular line from P to this line. Okay. Now you know that differentiation means the rate of change of y with respect to x, or change in y coordinate by change in x coordinate. So clearly here slope is what? Change is delta y divided by change in x, that means delta x. So see here, this distance is y1 and this distance is what? Y2. So clearly change in y is what? This distance only. So that is y2 minus y1. Similarly, this distance is what? See here, this distance is x1 and this distance is what? X2. So clearly change in x is what? This distance only, that is x2 minus x1. So clear, this is called what? Slope. If you take any 2 points on this line, then the difference of y coordinates by difference of x coordinates does not change. So it has the fixed value. That fixed value is called slope. So simply this is called what? Dy by dx. Okay. The rate of change of y with respect to x is called what? Differentiation. Or the slope of this line is also called a differentiation. For example, if any curves are given, then how to find the slope of that line? So using slope concept, we can conclude the differentiation definition. So see here, so consider the coordinate axis. So this is the coordinate axis, x and y axis. Okay. So for example, this is any curve. So this curve is y is equal to f of x curve. So how to find the slope of the curve? See here, how to find the slope of the line? If you take any 2 points on the line, then find the difference of y coordinates by difference of x coordinate. That is the fixed value. That fixed value is called slope. Here you can take any 2 points on this curve. This is P and this is Q. Okay. Now, so draw the line passing through these 2 points. So this line is called what? Secant line. Okay. For example, if you take any other 2 points, this is R and this is S. Again join these 2 lines. Okay. So clearly slope is increases. See here, this PQ line slope is less than the slope of RS. So clearly it not fixed value. So this is not a slope of a curve. So slope means it has a fixed value. So clearly that is not a slope of a curve. Now how can you find the slope of a curve? So see here. So this is y is equal to f of x curve. Okay. Now this is point P and this is the point Q. So this is what? Secant line. This is a secant line. Now here, draw the perpendicular line from P to x-axis and Q to x-axis. Again draw the perpendicular line from P to this line. Now, for example, this point P is what? X comma f of x. Okay. Suppose this distance is what? H. So this distance is x. Okay. Now, what is Q point? So clearly this horizontal distance is what? X plus h. So here P is x comma f of x. Then Q is what? So here total horizontal distance is x plus h. So Q point is x plus h comma f of x plus h. So what is the slope of this secant line? See here, slope of PQ or secant line is what? F of x plus h minus f of x. Difference of y coordinates divided by difference of x coordinate. But this is not a slope of a curve. This is what? Slope of a secant line. Here you need to find the slope of a curve. Okay. See here, for example, if both points are coincident. See here, if Q tends to P, the point both Q and P are coincident, then what is the distance between these 2 points? So clearly there is no distance. So because of these 2 points are equal. Now in that case h tends to what? 0. The distance is what? Tends to 0. When if Q tending to P, then h tends to 0. That means this secant line tends to which line? Tangent line. See here, like this. So this PQ secant line tends to tangent line. Okay. At point P. If you take any 2 points on this line and find the difference of y coordinates by difference of x coordinate, the constant value does not change, then we can say that that is the slope of the tangent line. That means slope of the curve. So clearly limit h tends to 0, f of x plus h minus f of x divided by x plus h minus x is what? H. This is called what? Slope of the curve. Okay. So you know that slope of the curve or slope of the line is what? Differentiation. That means the rate of change of y with respect to x is called derivative. So here it is denoted by dy by dx. This is what? Slope of the curve. So this is also called first principle. Okay. Here this is also called as first principle. This is also called first principle. And this dy by dx also denoted by derivative of x, f dash of x. When if y is equal to f of x, then f dash x is also equals to dy by dx. This means rate of change of y with respect to x. Okay. So using this first principle, you can find the derivative of the some functions. So this is the concept of differentiation. So therefore clearly from above concept, so clearly f dash of x is equals to what? Limit h tends to 0, f of x plus h minus f of x by h is called first principle. Is called what? First principle. in bracket you should write where y is equals to what? F of x. Simply this is also called dy by dx. So this is called what? First principle. So using this first principle we can find some formulas, derivative formulas. See here, the derivative of constant function, the derivative of constant function is what? How to find the derivative of the constant function? So see here, that means what? D by dx of constant is what? See here, for example, consider the coordinate axis. So this is both x and y axis. Here function is what? Constant function. So you know that constant function is always parallel to x-axis. For example, y is equals to 2. So this line is parallel to x-axis at a distance 2 units from the x-axis. So clear, this line is called what? Y is equals to 2. So you know that if any line is given, then how to find the slope? If you take any 2 points on that line, then find difference of y coordinate by difference of x coordinate. So that slope is defined as derivative of the function. Now clearly this line is parallel to x-axis. We know that the slope of x-axis is what? See here, slope of x-axis is equals to 0. Therefore, if any line parallel to x-axis, then that slope also 0. Therefore, slope of y is equals to 2 is 0. So slope is nothing but derivative. Therefore, derivative is equals to what? 0. So what is y value? 2. That means derivative of constant value is always 0. So you can find using first principle also. See here, y is equals to 2 means f of x is 2. F of x is was 2. You can substitute any value of x, then outcome value does not change. That means f of x plus h also 2. So substitute these two values in the first principle. F of x plus h is what? 2. And f of x also 2. So 2 minus 2 is 0. So therefore derivative is what? 0. So from this we can say that the derivative of constant function is always 0. So here are some properties. So these are also formulas. Okay. First one, let f of x comma g of x are any two functions. Any two functions. So then, see the first one, d by dx of f of x plus g of x. This means sum of two functions. If sum of two functions are given, then how to find derivative of that function? So here, this can be written as find derivative separately. That means d by dx of f of x plus d by dx of g of x. So derivative of f of x is what? F dash x plus g dash of x. For example, difference of the two functions is given, f of x minus g of x. In that case also, we can find derivative separately. That means here minus, here also minus. And second one, d by dx of c into f of x. So constant into function f of x. So in that case, this constant right outside of the differentiation, that is c into now d by dx of f of x. Simply this is what c into f dash of x. Now see the third one, d by dx of product of two functions are given. So here you need to find differentiation of product of two functions. By using first principle, you can find the derivative of this function. So otherwise, write directly. That is f of x. Okay. In first case, this function treated as constant term. So see here, second one, how to write the derivative of constant into f of x. So see right outside of the differentiation. So clearly here f of x is constant, f of x right outside of the differentiation. Then d by dx of next function, that is g of x. In next case, second function treated as constant. So write g of x first into d by dx of f of x. So this is f of x into d by dx of g of x is what? G dash of x. Plus g of x into d by dx of f of x is what? F dash of x. Okay. So this is the product of two functions. So here this can be also written as d by dx of u v, means u of x into v of x. This is u into derivative of second function, that means dv by dx, plus v into derivative of first function, that is du by dx. So simply this is u into v dash plus v into u dash. So this is the derivative of product of two functions. Okay. Next, differentiation of division of two functions. See here, d by dx of u by v or u of x by v of x. So this is equals to v into denominator into derivative of numerator, that is du by dx, minus numerator into u into derivative of denominator, that is dv by dx, divided by denominator square, that is v square. Okay. So simply derivative of u by v is equals to what? V into u dash minus u into v dash by v square. So this is the derivative of division of two functions. Okay. See the fifth one, chain rule. That means d by dx of f of g of x. So clear, this function is called a composite function. How can you find the derivative of the composite function? See here, this derivative is, so clear it in the form of f of x. Okay. So you know that d by dx of f of x is what? F dash of x, where x is g of x. So write f dash of g of x. But in place of x, g of x is there. Some change is there. Okay. Again, we have to differentiate the changed value. So here that means d by dx of, in place of x is what? G of x. Again, we have to differentiate the changed value. That means this is f dash of g of x into g dash of x. So this is the derivative of composite function. So these are the few properties in differentiation. For next session, I will discuss more concept.